Hello guys, my name is Noam Moshe, and today I'm going to present to you JSON security off, or how we abuse JSON syntax to pwn cloud applications. So a short word about myself. I'm a vulnerability researcher at Clarity Team 82. At Clarity Team 82, we do responsible disclosure. That means that we target very interesting, be it physical devices, SCADA, IoT devices, applications, cloud applications, basically everything. And we report the vulnerabilities we find to the vendors. And as you can see, we have a very cool lab that we get to have a lot of fun with. I personally love researching cloud and web applications because the vast scale it offers when you find one vulnerability. And lastly, we are also participating in hacking competitions and CTFs, and we are actually participating in Pwn2Own Toronto right now. So we have a big week on our hands. So let's talk about our agenda for today. Today I'm going to present to you a research I've done in the last year where we found a few cool cloud vulnerabilities. And when we tried to exploit these vulnerabilities, we actually got stuck. You see, we were blocked by AWS security mechanism, more specifically a WAF. And that threw us in a loop, and because of this, we had the need to bypass this WAF and be able to exploit our vulnerabilities. We were able to do this by analyzing how a WAF works and how it flags requests as malicious and as safe. And through that, we were able to actually find a generic WAF bypass that we tested against all WAF vendors. And in all cases, it just worked. Plain worked, nothing out of the box, just send it and forget it. And lastly, I'm going to present some tools and open source stuff we wrote that you can use this research on your own. So, late last year, we were researching a company named Cambium Networks. Now, Cambium Networks does a lot of wireless communication devices, be it access points, long-range access points, antennas, 4G routers, basically every kind of wireless connection you can think of, they do it. And in this particular case, we weren't looking at the physical devices themselves, but instead we were looking at a platform called CNMaestro. Now, CNMaestro is a platform that allows IT administrators and system administrators to take a look at their devices, see their location, status, configurations, and even perform some actions like push a new firmware, push new configurations. It basically allows them to control it. When we talk about how CNMaestro is built, it is built in either one of two flavors. It is either an on-prem solution that a company buys and installs on their own machine, and then all their wireless access points connect to this machine and are managed by it. Or the second, in my opinion, more interesting flavor is a cloud deployment. And in this deployment type, I sync my machine to the cloud, and I can manage it through Cambium's application. And of course, luckily for us, when we went to Cambium's cloud, we noticed that we can register. We can just register freely, and that put the cost of entry to this research at a 0, because we just registered. And when we registered, we noticed that a new instance, a unique instance of CNMaestro is being set up, and we were able to access it through a unique GUID through a URL. Now, this gave us two options. We could either black box the cloud, meaning we could try and find vulnerabilities on the cloud platform itself, or, and in my opinion, the better version is to research the on-prem solution, because we noticed that it actually looks the same, and it might have a similar code base. And once again, we were lucky, and we were able to just download this solution out of their website. And when we downloaded it, we noticed that it is in an OVA, and we can just plug it into our favorite virtual machine software, be it VMware, VirtualBox, whatever, and then we have access to CNMaestro. Inside OVA, there was a very basic Linux distribution with a lot of proprietary code and a lot of proprietary services that actually manage the physical devices themselves. Now, most of the services were written in Node.js, so that's our exploit path, trying to exploit a Node.js application. And inside of it, there are many different servlets that serve different functions, be it allowing administrators to connect to the application, sending commands to the cloud, etc., to the devices, etc. And there are actually many of them, around 10. Pretty soon enough, we reached a very cool SQL injection vulnerability that basically allowed us access to the database. This happened because they just appended user data in a route that took max serial number of devices into an SQL query, and we were able to inject malicious SQL syntax to the database. What can we do with this vulnerability? It's very simple. We can start exfiltrating data. A lot of sensitive data is being saved in this application, be it cookies, tokens, SSH keys, everything that's interesting to us. But sadly, we could not do it. You see, we started our process into building our payload, meaning taking the vulnerability and creating an exploit out of it. And that's where we had a lot of hurdles and stuff that we had to come by. First of all, when we tried to exfiltrate simple text, we got an exception. The main route of this vulnerability only allowed us to exfiltrate device IDs, meaning integers. So we had to take the text that we want to exfiltrate, be it SSH keys, be it cookies, and convert it to an integer. And using some SQL magic, it's pretty simple. You can just take a text, split up into an array, and returning rows of characters. And then you need to convert it into integers. And then we were getting the ability to exfiltrate some data. But that wasn't enough yet. You see, when we exfiltrated data, we noticed that the data comes in a scrambled order, meaning we don't save the correct order of a word. Once again, we fixed it with pretty simple SQL magic. We just took the index of each character, multiplied it by 1,000, and then by doing a simple division calculation, we can extract both the character and the index of the character. Lastly, this endpoint was very, very slow, and we wanted to exfiltrate a lot of data through it. Meaning that when we tried to exfiltrate, for example, all of the users or all of the users' password, we got timed out because each exfiltrated row was returned in a different row, and the multiple actions were performed on it. And once again, we can fix it pretty easily with SQL. I know it looks a little bit funny, but simple SQL syntax that basically constructs one big integer out of 7 characters and returns 7 characters in one returned value. Cool. Now, this is where I usually just send my boss an ambiguous message like, hey, we did it, and then I ghost him for the next 7 days. So we tried to take this vulnerability to the cloud, and we were blocked. I kind of spoiled it at the beginning, but we were blocked. You see, our request returned forward 3. And after a few minutes of complete shock, and we didn't know what to do with ourselves, we noticed this cute thing in the response. And this header, server, AWS CLB, is what triggered our entire research. You see, we were blocked by AWS WAF. AWS WAF is a web application firewall. It basically looks at the request and response that users send to an application and tries to flag them for malicious SQL injection, shell injection, OS command injection, and XSS attacks. And our goal was to exfiltrate all the juicy data that was saved on the cloud. So we had to find a bypass. That's where we created a very unique AWS setup of our own with the intent to try and analyze how it works. And in the next 3, I said 3, it took more like 12 days, I just was sending payloads and trying to see what gets blocked, what doesn't get blocked, and how the WAF could flag requests as malicious. Now, I'm not a WAF developer myself, so don't take tips from me, but if I was a WAF developer, that's how I would flag requests as malicious. I think there are at least 2 approaches, and most of the time you need to combine multiple approaches in order to flag a request as malicious. The first approach is to look for blacklisted SQL syntax. For example, we know that select, we know that union, we know that like are clearly SQL directives, and if we see too many of them in a request, we can simply drop it. The second approach, which I think is a little more complex, is try to understand SQL syntax from the request. Meaning, does this payload can construct an SQL syntax in some specific conditions? But that's what started our research question. What would happen if there was SQL syntax, valid SQL syntax, that the WAF did not know of? What would happen if we can confuse the WAF and make him deem as a payload as non-exploitable and non-SQL, even if it would? That's when I'm going to introduce to you JSON in SQL, which kind of spoiled the whole thing, but that's the answer of this syntax. What is JSON? JSON is one of the most common data format in the world. We use it constantly. And more specifically, we use it as in web APIs, in requests to store data and to save it and to send it to different servers. And currently, all SQL databases have added native JSON support for their implementation. But why should we use it as developers? Well, I'm not a developer once again, so I asked a few of my friends and asked them, hey, why would you use JSON SQL? And they told me, yeah, because we can just work with JSON directly in SQL, meaning we can increase our efficiency, for example. Instead of doing a lot of API calls and database calls to the database itself and fetching data and trying to pre-process it in a way of JSON, we can just immediately return JSON data from the SQL itself. And because we work with JSON so much, it could help us a lot. And that's basically the process. You can take a table, use some SQL query to modify this and parse it as JSON, and then just return the data as JSON completely. When we look at JSON support in SQL, we see that all database engines support SQL, in some cases as soon as 2012. In the case of Postgres, most of them added proprietary support, proprietary parser, and everyone added functions and operators of their own. So we can see different SQL syntax in all database engines. That's when we get to the cool stuff. That's like the intro. We are now going to construct new SQL injection payloads. We all know that in SQL, in at least blind SQL, we try to create true statements, meaning does this password equal to the admin password? The answer is no, but we can modify the SQL syntax and change it to do, does this password equals to the admin passwords or a true statements like 1 = 1. And that's when we created new SQLite payloads using JSON. Let's take a look at this operator as an example. It basically translates to, is the left JSON contained in the right JSON? And we, of course, can create situations where it is true, and we can create a simple SQL payload that basically translates to true. A similar payload can be created in MySQL with the function JSON extract that basically extracts a value using a key. And once again, it's pretty simple to create a true statement. And lastly, we have this operator that it basically translates to the same thing, JSON extract, and we ask it to extract the value with the key A. And combining multiple payloads, we can create some monstrosities, some very, very confusing SQL syntax that will for sure confuse the WAF. So after we have some basic understanding of JSON in SQL, we can start to test our theory that maybe the WAF won't know of it. And when we go back to our setup, we tried a good old-fashioned tag or A = A or 1 = 1, and of course we get blocked because the WAF knows this payload and can immediately flag it as malicious. But when we try our new JSON-based syntax, we can see that the request passes by. And that's because the WAF doesn't know how to parse our new syntax. And it just decides, yeah, that's not SQL. It can't be SQL, so I'll let the request slide by. Now, let's get back to the case at hand. What was our goal? Our goal was to bypass the WAF, which we just did, and exploit our vulnerability. We want to use our SQL injection, bypass the WAF, and exfiltrate admin tokens, other users' tokens, SSH keys, private keys, everything. And to do so, we've created this monstrous payload. So let's do a quick rundown of this payload. I know it looks intimidating. Basically, in pink, we have the first part of the payload. It's the WAF confusion part, as I like to call it. All we are doing here is we are creating an SQL syntax that the WAF does not know of. And when it encounters this syntax, it basically gets confused and says, yeah, that's not an SQL statement, because it can't be. It's not SQL syntax. And this part basically completely bypasses the WAF. Then we get back to the three limitations we had before. The first one is our vulnerability must return integers. So once again, we simply return integers. We cut each character into a different row, and we return integers. Then we have the problem of the characters getting all jumbled up. Yeah, we fix it. We simply append the row number. And lastly, we create a big int out of several characters, and then we can reconstruct it later. And using this payload, it actually worked. We finally had the ability to exfiltrate arbitrary data from the database, and we basically pwned them. Now, let's say consequences. When we pwned this, we were happy over the moon. We finally had the ability to control all Cambium devices that are connected to the cloud using this simple, very simple, it's basically an SQL injection. Using this simple vulnerability, we were able to pwn all the access points that were connected to the cloud. We were able to manage them and perform actions on them. We reported this issue to AWS, and they say, yeah, that's right. We're not supporting JSON in our SQL syntax, and they added support. And then we said to ourselves, yeah, that's cool. We have a WAF bypass of AWS. What can we do with it? And we did the only logical thing, and we decided to bypass all other WAFs. You see, we thought to ourselves, maybe we have a core concept. Maybe not just AWS doesn't know of JSON syntax, maybe we have a bigger problem. So one by one, we started testing against different WAF vendors, be it AWS, of course, at first, Cloudflare, F5, Imperva, and Palo Alto. And every one of them fell like a fly, and not realizing that we are passing SQL syntax. Bypassing WAFs is cool and all, but we thought to ourselves then, after we managed to bypass all WAF, yeah, let's do it automatically. So we reached the conclusion, what can we do? We can modify a very cool tool. We all know of SQLmap. SQLmap is one of the most common tools in web application penetration testing. It basically allows you to point it to a vulnerable endpoint, and automatically it just starts generating payloads and exfiltrate data. And SQLmap is vast, and it supports a wide range of the databases, different cases, what specific flags are enabled in the database, and it just works. We added a new module to SQLmap that basically takes the payload that it generates and modifies it in some way. And this specific way is actually adding WAF bypass and JSON syntax to the payload, thus being able to bypass WAFs. So in order to demonstrate how it works, we did the only logical thing. We created a very vulnerable web application, very simple logic, simply take something from the user and insert it in a SQL query. And we placed it in between, we placed Palo Alto next generation firewall in between us and the application. And now our application was protected. And when we used SQLmap out of the box, yeah, it obviously didn't work. We can see that every request got dropped. And this was done, this is because the WAF recognized each request as malicious and simply dropped the request. Then we used our script, our new module, an SQLmap, and it actually worked. Now we have a vulnerable endpoint, and we are able to inject arbitrary SQL payloads. And this is how it looks. We are running SQLmap at the same time, and we can see on the right that every request gets dropped. And on the left, that's our tampered version, and we can see that SQLmap recognizes it as vulnerable. Well, let's talk disclosure. After we managed to bypass all WAF vendors, we went one by one and started disclosing our findings to them. We started with AWS and then moved to the rest of them. And one by one, each said to us, yeah, we don't have JSON support, we must add it. And now we can say that most WAF vendors actually support JSON syntax in their SQL parsing engine. But let's think a little wider. Yeah, cool, JSON is cool, I guess. Maybe we have something bigger. Maybe we have a core concept. You see, a WAF cannot actually parse SQL fully because it has a little limited time. It sits between you and the application, and it should just work immediately. It should make decisions immediately. We see that all WAF vendors didn't add JSON support, even though it is supported for more than 10 years. Why is that? Again, that's exactly because they can't fully parse the SQL. Think about how many other SQL features that are prevalent in all SQL database engines are out there. Think about how many other features, be it asynchronous action, be it other data formats, CSV, XML, that are out there and enabled by default, just like JSON, and could be vulnerable and be used to bypass arbitrary WAFs. Let's do a quick rundown of what we did. We basically found a very cool vulnerability, tried to exploit it, and got stuck. And we thought to ourselves, yeah, we're fucked, and we could have just said, let's leave it, not vulnerable, that's okay. But instead, we took the time and effort to try and analyze and black box how a WAF works, and we managed to bypass it. And for the first time, at least that I know of, we have a generic WAF bypass, meaning I don't care what kind of WAF sits between me and the application. I can just send it and forget it, which I think is pretty cool. Also, like we've shown, JSON is very new-ish in SQL. It goes between 1 year, 10 years. It depends on the SQL database. And each SQL engine decided to implement JSON parser of their own. Each of them is proprietary, and we believe there is some differences. So you can wait for this research we're going to do soon, presenting the differences between different database engines. And lastly, give it to the community. If you have a new concept, do add support for it in openly available tools, because I believe it's cool. So feel free to use SQLmap with our new feature. Are there any questions? If there are any questions, you can go to the mic.